A hurricane is formed when the temperature difference between the ocean's surface and the air, 10 to 15 kilometers up, is too great. This is not the only cause, but it is an essential condition. For a hurricane to develop, ocean scientists teach us that other conducive conditions must also be met. Hurricanes do not form when weather conditions over the ocean are too irregular. With these conditions met, a tropical storm can turn into a hurricane. A new structure composed of both disorder and order, with the appearance of an eye and the wall of that eye. The order in a hurricane manifests in the form of a huge solar power plant that provides the motive power the hurricane needs to strengthen and grow more powerful. The proposed method for weakening a hurricane consists of tracking it and injecting massive amounts of cold water continuously into specific areas. The control system that develops as the hurricane forms is severely disrupted, causing the hurricane to gradually self-destruct and regress to a tropical storm. Hurricanes are structures that form at sea using the laws of physics. We propose a method and an apparatus called a Vistemboir that uses those same laws to weaken hurricanes. The orderly structure of a hurricane is able to form thanks to the second law of thermodynamics and the chaos theory, provided that the order is offset by at least an equivalent disorder in the rest of the system. We make use of the second law, which is confirmed by information theory. It will be supported by the principle of worst action, which can create great disorder on a microscopic scale. The principle of worst action contrasts with the laws of chaos that allow a hurricane to form. Where can we find cold water to destructure a hurricane? Why, a few dozen meters below the surface of tropical seas. We just have to go and get it. But the laws of physics tend to keep the cold water where it is, making our plan more difficult. Mechanical energy is required to bring cold seawater to the surface. On this slide, we see that it would be better to pump water to a depth of 200 meters, where the temperature is 15 degrees lower than at the surface. Moreover, this temperature difference, depending on the depth of the tropical seas, is a potential source of mechanical energy, according to the laws of thermodynamics. This technique is known as ocean thermal energy conversion, OTEC. It has been understood since 1930, and is currently under development. OTEC is mainly used to generate electrical energy for islands. We propose here to separate OTECs from coastal islands and turn them into sea vessels. Cold water must be pumped from deep down, so the apparatus must be at least 200 meters tall. It must be able to move at a speed of 15 miles per hour, the average speed of a hurricane. The good news is that hurricanes travel at moderate speeds, so we should be able to follow them across the ocean. These two requirements mean that we would need a megastructure, such as the one seen here, a kind of submarine designed to track the hurricane. It would be controlled remotely from a base. Mechanical energy, produced by the main engine, would propel the underwater vessel and pump cold water. A secondary engine would balance and stabilize the device. It would draw power from the main engine to run its own propellers and accessories. This draft solution is exciting, because the treatment of a hurricane then becomes a local operation that requires no outside intervention. The main engine would run on OTEC technology, although a better alternative is an air-independent propulsion (AIP) system for AIP submarines. AIPs can operate for several days underwater without air, making them a good candidate since hurricanes tend to die down after about a week. Cooling modules would be built onto the main and secondary motors so that the unit forms a hydrodynamically stable system. All parts must be designed to reduce hydrodynamic drag, and match the speed of a hurricane's movement across the water. Here is an example of the overall characteristics of a hurricane Vistemboir. Diagramming it results in the following power distribution. Pump and engine power, 56 megawatts. Pump power, 16 megawatts. Power required to overcome hydrodynamic drag, 40 megawatts. Following a hurricane requires a lot of energy. It takes 40 megawatts of the 56 megawatt produced to overcome drag. But let's not complain. Nature has given us a remarkable gift by limiting the speed of hurricanes moving across the ocean, allowing us to follow them and inject about 400 cubic meters of cold water per second into their base. The natural tendency of a self-organized hurricane system is to increase its power through exchanges with the environment, using collective intelligence to drive the hurricane towards the hottest and most consistent areas of the ocean. The information provided by its immense molecular system guides it towards areas where it can thrive. It is this control system that must be disrupted until it breaks down. To weaken a hurricane, we must scramble its molecular organization. We do this by disrupting it with a massive injection of cold water into specific locations. A hurricane has considerable power, equivalent to hundreds of 1,000 megawatt power plants. It would take a fleet of Vistemboirs to destabilize it. The Vistemboirs would have to be sent deep enough that surface disturbances would be minor and acceptable. One knows, in this respect, that the eye is a relatively calm region. Let's use the example of a hurricane in the North Atlantic to illustrate our proposed solution. Armada 1 would be positioned under the eye wall in the area marked on the slide, under the hurricane's axis of movement, about 20 kilometers upstream of the eye wall. In a second action, we would position another fleet of Vistemboirs, Armada 2, under the wall of the eye, along the tangent parallel to the hurricane's axis of movement. With the armadas in place, local cold water injection could begin. The purpose of these actions is 1. To gradually break down the cyclonic system by weakening the correlations between the billions of molecules forming the immense self-organized structure, i.e., by introducing disorder into the orderly part of the hurricane. 2. To weaken the system by introducing shear into the winds that rotate in a spiral around a wall of the eye. 3. To change the hurricane's trajectory by injecting cold water. At the above-mentioned locations, we should be able to keep the hurricane from traveling towards warmer waters. The cold water injection is intended to change the hurricane's behavior. Molecules near the ocean's surface will tell the entire molecular system that water is cold to the west-southwest, and that the whole system should head north-northwest instead, where it will be better able to feed and grow. 4. To push movement northwest using the Coriolis effect. The further north the hurricane travels, the more the Coriolis effect will deflect it to the right. Meteorological phenomena over the ocean can be characterized by a control parameter, CP, that is determined by multiple observations. It is a function mainly of the ocean's surface temperature, but it is also sensitive to other elements such as wind shear. As long as the system is a tropical depression or tropical storm, the energy will dissipate. When the control parameter increases, the system crosses a bifurcation, with somewhat chaotic phenomena, before forming a hurricane structure. The order that appears, when the hurricane forms, generates an immense thermal turbo machine. The entropy of the meteorological system decreases as the hurricane forms, in accordance with information theory. A system that receives information grows organized, and its entropy decreases. This order extends the life of a hurricane, a natural phenomenon that may be spectacular, but is destructive to humans. By deteriorating the consistency of the information received, it should be possible to weaken a hurricane, meaning to destabilize it. Cooler molecules introduced locally at specific locations, and in sufficient quantities, at the base of the hurricane wall will alarm the hurricane's control system, which will disorganize and weaken. When the system becomes a hurricane, and energy dissipation is disrupted, the principle of worst action is applied to destroy the orderly part of the hurricane. This occurs using a hurricane Vistemboir. The action must continue until the hurricane self-destructs, and downgrades to a tropical storm.